All right, so here we go with yet another rational function that we want to graph. We might actually have a little bit more work to do with this one. The first step is to make sure that everything is factored completely. So in the numerator, this factors as x plus 2 times x plus 3. And the denominator, x squared minus 4, is the difference of squares, so that's x plus 2 times x minus 2. So if we're talking about our domain, it's the set of all x such that x does not equal, again, look to that denominator. From this first factor, x cannot equal negative 2. And from the second factor, x cannot equal positive 2. And if we're doing the whole interval notation thing, so negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. All right, the second thing is to write our function in lowest terms. So these guys reduce, and it gives us x plus 3 over x minus 2. Now again, we've mentioned this in previous videos, but this is going to be with the caveat where x does not equal negative 2. So you can't say, oh, we removed x plus 2, so that means that we don't have to worry about that being a restriction in the domain. Not so. That's why the first step is to factor and identify what the domain is. And then the second step is to look at it in its reduced form. Okay? So be very, very careful about how you do that in the steps. Now, because I reduced a factor away, that means that we do have a hole. And so the hole is going to be for that x value that we reduced away, which is the negative 2. We were able to kind of take away that discrepancy. And to figure out where this hole is going to be, plug negative 2 into this expression. So even though this function originally is still not going to be defined for negative 2, we can still come up with a location for the hole. So plug in negative 2, and we end up with positive 1 over negative 4, so that is negative 1/4. All right, step 3, let's talk about the y-intercept. We can plug in 0, we can plug it into the original, we can plug it in here, doesn't matter, it's still going to be the same. We plug it in, we end up with negative 3/2. Okay, so we already have a couple points, this is great. Let's go ahead and talk about your x-intercept. Now, this x-intercept has to come from the reduced form, okay, not from the original. So if we set this numerator equal to 0, that tells me that negative 3, 0 is our x-intercept. All right, step 4 is to identify the vertical asymptote, or asymptotes, if any. But it has to be from that reduced form. So from here, what makes that denominator 0? That's going to be x equals positive 2. We identify any horizontal or oblique asymptotes. So to do that, we have to compare the degrees. Now, whether you compare it up here or you compare it down there, they're going to have the same degree. And because of that, we look at the quotient of the leading coefficient. So 1 over 1, and that's just 1. So we have a horizontal asymptote of y equals 1. All right, so let's start to put this information together and see what we have. So we have a vertical asymptote at x equals 2. So let's get that on here. Horizontal asymptote at y equals 1. Now the other key points that we have negative 3, 0 for an x-intercept. So negative 3, 0 for the x-intercept. 0, negative 3/2 for the y-intercept. So by putting those 2 points in the lower left, that tells me that I should have a graph that curves and goes down like that. And since where I got my vertical asymptote from was just x equals 2, and it wasn't squared, I would expect it to come back up here and finish going out that way. Now let's use point symmetry to kind of flesh out the rest of this. This point right here, relative to where these guys intersect, is 2 to the left and down 1, 2.5. So let's go 2 to the right and go up 1, 2.5 to get another point. This point right here that is our x-intercept is 1, 2, 3, 4, 5 to the left and down 1. So let's go 1, 2, 3, 4, 5 to the right and up 1 to get another point. And then finally we have our hole, which happened at -2, -1/4. So -2 and -1/4, something like that. So that means over here, because we have that hole, our graph does not get to go through that hole. It's going to curve down like so. And then get closer to the horizontal asymptote there. And then here, we use these points to help put the curve in the right spot. Just like that. All right, now let's check with the calculator. So in the numerator, now we want to go for the original guy. The original guy was x squared plus 5x plus 6 divided by x squared minus 4. All right. So let's graph this and see what we have. Yeah, that's what I've got. There's a y-intercept. Now, what you won't see is the hole. It doesn't automatically graph that unless we change the zoom, right? So if I go z and I go to z decimal, now you can see the hole show up. So the hole shows up right here at -2 and -1/4. So exactly what we were showing, and now you can actually see that show up on the graphing utility. All right, now the next one that we have is going to be a little bit crazier in terms of what the end behavior is. So be very careful with your notes.